So we're here at the rink, and basically I just wanted to go over the piping systems and valving and things of how we built this boiler room and understand the flows. Before I'm done with this project, all of these pipes are going to be labeled with what they are: glycol supply, glycol return, flow arrows, different sensors that Carl and I installed. We're going to put sensor numbers on them that all correspond to the as-built drawings from an electrical standpoint. And then the entire floor is going to get painted as well. So we've still got some work in here left to do, but that'll be ongoing. So in a nutshell, there's two different systems here. There's an 8-inch main glycol system, which is your cold floor, and there's a 3-inch glycol system, which is your warm floor. Obviously, the warm floor is below the cold floor. So I'll start with the cold floor piping. Main return comes in here. You got temperature thermometers on each of the supply and return. Comes through here, goes through an air separator designed to purge out the air. Once you get the air out of the system, which we have, this isn't used that much more unless there's been air introduced to the system, which we don't want to have that happen. But anyway, it's an air separator that's in the system. Basically, that 8-inch line comes down here, goes to the suction of both of these pumps. You've got shut-off valves here, pressure gauges here on the pumps. Goes through the pumps, comes up off the discharge. This is a balancing valve. It's called a triple duty valve. It's actually a shut-off valve, a check valve, and a balancing valve. So any of these valves that you see in here, Carl has already pretty much balanced these valves as part of his commissioning process. It's not a set and forget type thing. For Carl, it is to commission the system in the sense of getting the right refrigerant flows in the chillers, as well as temperatures out to your rink, your cooling tower, your heat exchangers. So he's commissioned all that. I'm going to be sending out his certified report, which he sent me yesterday. Got to review it. I'll send it out to the team so that everyone has a copy of that. But in essence, cold glycol is coming back here, goes up through the pumps, tees together. All of these pumps in here that I'm going over are really primary and standby pumps. There's always only one pump that needs to run, and there's always a standby pump if one should fail. Comes up in here, it goes through this, and this glycol loop out to the rink, it's basically a primary and a secondary loop. There's two loops here. So if you follow the return back into there, it comes up, it joins together, and all this does is go right back out, back here, and back out to the rink. So all these pumps are doing is circulating water through your rink bed, or glycol through your rink bed. That's all it does. I call that the secondary system. The primary system is Carl's chillers. So this valve you see up here is a normally closed valve. We put that in for maintenance reasons. We put it in also for some balancing issues if we've got to test certain things. But once it's commissioned, that valve is always shut. 8-inch valve that's up at the top is a normally open valve. So the glycol is just going to circulate all the way through here, all the way out to your rink at all times. If these chillers start, when one chiller or two chillers, depending on the load, it actually siphons glycol off of this primary or secondary loop, and it goes through a primary loop of one chiller, two chillers, or three chillers. And this is basically injecting cold back into the rink to maintain your ice. That's essentially what this does. So this loop goes back. At the very end, there's a small 2-inch equalizer connection with a ball valve on it. I'll show you that in a minute when we walk down. That's normally closed. And again, it's only used in balancing purposes initially, but that'll always stay closed. And the cooling tower, the cooling system loop is just going to have glycol going out to the rink to maintain the cold, glycol. To cool these compressors, and Carl will go over the chiller arrangement in a minute, but to cool the compressors, there's a 6-inch warm glycol loop that goes out to your cooling towers or to this heat exchanger behind us. So the way that system runs is the hot glycol coming out of the chillers that needs to be cooled, coming out on this pipe right here, goes through another air separator to purge the air out, comes this way, comes down into pumps P3 and P4, which is your warm loop glycol pumps, and basically pumps up. It goes through your heat exchanger, and that is the heat exchanger to go through and back up, and it just loops back to the chillers. So this heat exchanger on one side, the steel pipe side, has glycol on it, warm glycol from the chiller system. The other side is just water for your cooling tower. So what it's doing is exchanging the heat between getting rid of the heat in the chillers out to the cooling tower, and the cooling tower is doing its job. So in essence, that's just a standard, cooling system for cooling the compressors. Again, there's temperature sensors all in these pipes. There'll be a full as-built drawing that shows what they are and what they do. I won't bore you with those at this point because they're more integral parts that you'll see when you do the training on the chiller system. You'll see where these control points are. It'll mean a lot more to you. The other thing that we do is, as an energy-saving method, is obviously we've got to heat the warm floor with the 3-inch piping. So what we do is we capture some of that heat before it goes out to the cooling tower and use that heat for the warm floor. So if you can see right here, before it goes into these pumps here, is what we call a bridge connection right here. This 3-inch pipe and this 3-inch pipe here. We're pulling off of this loop before it goes through the heat exchanger to come over, down, through these 2 wall-mounted pumps, P8 and 9, and that's what's connected to your warm floor. So we're pulling that heat off before we reject it and waste energy on your cooling tower to dump the heat in your floor. It comes back, and then it just dumps back into the same pipe. So just like you have a bridge connection here for the chillers and the cold loop, you have a bridge connection here that's just pulling that heat out and dumping that cooler glycol back in the loop again so that the heat exchanger and the cooling tower doesn't work as hard doing that. And then the final thing is you're preheating your domestic water. That also comes off this glycol loop. So what we did here is, you can see that copper pipe off the top.
Yep.
It comes over, it ties into this copper pipe, and it goes through the wall up into your Zamboni room. And that is the entire preheat system for your Zamboni water, for your showers, what have you. So we're doing 2 things. We're pulling off that warm glycol loop to preheat your warm floor, but also we're grabbing whatever heat we can to preheat domestic water.
Okay.
So those systems are always going to run whenever the chillers run. So we're always going to be preheating the water. If the water's already preheated enough, it's just not going to reject any more heat. It's going to dump it to this heat exchanger, and this one is the workhorse that'll work to send it out to the cooling tower.
Okay.
So in a nutshell, that's the 2 main piping systems. Glycol loop for the rink bed, glycol loop for the warm floor, and your condenser system. The cooling tower loop is very simple. We just comes from the bottom of the cooling tower, goes into this sump tank. All it is a holding tank. When the cooling tower shuts off, the water's got to go somewhere because we don't retain water out there. It just dumps it into a holding tank. And at that point, these are your pumps P5 and 6, your cooling tower pumps, strainers. They just basically come up. It goes into the heat exchanger, out of the heat exchanger, and back up to the cooling tower. Very simple loop to maintain that cooling that you need for the compressors. The other system while I'm here is your chemical treatment system. I'll explain a little bit in the corner over there, but seeing that we're here, this is a coupon rack, and right now we own, for the first year here, we have someone coming in monthly to do the chemical analysis to make sure that the cooling tower has the right chemical percentage that you need, and it has the anti-corrosion chemicals, which are in 30-gallon pails that I'll show you over here. But this is a coupon rack, and essentially what that technician does is he'll undo this and pull this out, same one over there, and there's an assembly in there that he can test as to what the corrosion level is of the cooling tower water that's through it, and he'll adjust the chemicals accordingly as well. This is obviously a water meter as well that's tied to the system, and that'll end up just dumping water into the cooling tower. So this is the other part of the chemical treatment system, strictly for the cooling tower. Nothing to do with your glycol systems at all. There's 3 pumps, 3 different chemicals that maintain the corrosion and conductivity level in the cooling towers themselves. Flow of water basically comes in through a conductivity controller and switch, and it'll just flows right back to the sump holding tank. But you've got a separate pump for 3 different chemicals with these injection taps in here. So that's how we admit chemical to the system based on this conductivity controller and what we should be maintaining for conductivity in the cooling tower system. Once the conductivity level gets too high, it's almost like a backwash that you're doing. This will sense it. It will energize this solenoid valve, and it'll bleed out water just right to the sanitary drain here until such time that that conductivity level comes down to an acceptable level. And then again, that's where the water makeup comes with the sump tank. So that's really the chemical system. As I say, there's plenty of gauges and thermometers that you guys can see and read visually of what you got for pressures and temperatures, but you really probably work from Carl's automation system, because that really is telling you what everything is doing down to the the real nitty-gritty. So that's much more accurate than just reading the gauge here. But we put these on as a visual as well. The other thing that we had here, and it's a code requirement, on the top of this pipe of the cold glycol loop, and there's another one on the 6-inch warm loop, there's 2 relief valves. In the event that the pressure in this system somehow should go a little higher than it should, we're running at about a 1 to 2 psi pressure on the suction side of the pumps. That's set at 25 psi. You should never ever get up that high, but it's a safety measure. If it does, it relieves and dumps that pressure out. So we've piped that over to a 55-gallon drum here, so we're not dumping glycol on your floor. It at least dumps it in there. So that should never be full, and it's something you might want to just check just by shaking the barrel, and if it's empty, that's a good thing, because there's no reason that there should ever be glycol in that tank. Same thing for the warm loop. That's set at 50 pounds, because we're running a little bit higher pressure in the condenser loop than we are in the glycol cold loop, but same theory. If it gets too high, it'll open up and dump into that holding tank. Other than that, you know, obviously all new lighting here as part of the electrical. You've got a brand new transformer outside to a brand new 1200 amp switch. All new conduits coming over here to the main distribution panel, where all of this then feeds a 480 to 277 volt transformer. And then you've got a main distribution sub panel. From that, all of the other panels that are in the building, in the corridor mainly, is where that gets powered from this panel here. And I'll go over the rest of the stuff in another day. When we're doing the HVAC training, we'll kind of go over some electrical training as well as far as where things are at. But just so you know, everything is brand new right from the utility pole. So you couldn't ask for anything better at that point. So other than that, 2 new unit heaters up at the ceiling. The old ones were existing to remain. I told DCI was probably not in their best interest to do that, so they opted for 2 new ones, and you get 2 brand new ones. There's also a refrigerant recovery system in here in the event that one of these chillers should rupture and there's Freon. The good thing about these is that they're 3 individual chillers, so the sum total of all of these chillers, if they should all fail at the same time and relieve refrigerant, you still have enough room volume here that refrigerant would disperse itself within the room. But as a safety measure and a code requirement, we still have to put in a refrigerant recovery system, or exhaust system, if you will. So we've installed a sensor at the bottom, the base of chiller number 2. Refrigerant's a little bit lower than air as far as where it goes, so if it does leak out, it's going to gravitate to the floor. Refrigerant sensor would pick that up, and right outside this door is an alarm panel. So that blue beacon that you see up there is a horn strobe. There's one outside the building, there's one outside this door, and there's one outside this door, 4 of them total. If you see those going off, you've got a refrigerant leak, you've got a refrigerant problem. So there's a number of different alarm systems between that system, the amber light that we'll show you in your office, which is really a chiller alarm system, nothing to do with the refrigerant. That means you've got a problem with the chiller system. But basically that's a code requirement. It's all been tested and calibrated for the R513 refrigerant that we have. And the state chiller inspector, John Lawrence, was here this week. We demonstrated all that to him. He accepted that, and he's since tagged these 3 chillers. So just like when he came out and tagged your boilers and put tags on them and gave you certificates, you'll be getting 3 certificates here for these 3 chillers. So if you could maybe just email me a copy of those, and I'll post them on site here. And then the yearly inspections will be up to you guys. The other thing within the chillers, there's relief valves that Kyle can show you, but there's only 2 per chiller, and they go up into this black relief pipe which vents outside. Again, just like these relief valves that I put in, if the chiller has a malfunction and they overpressurize, that relief valve will dump into that pipe and dump outside, so it gets the refrigerant safely outdoors as opposed to in here. Those relief valves have a tag on them, and those have to be changed every 5 years. So that'll be part of your master plan of doing that. And I mean, I know Rico does that, or ARC does that on all the DCR chillers as a maintenance issue. The relief valves I was referring to as far as maintenance, each chiller has 2. There's one here with a tag and one here with a tag. So other than that, I think that's all we have. There's really nothing left to do. Some minor insulation patching and painting the floor, and I'll do all the pipe labels and things myself, and valve tags, and there'll be a chart on the wall with any valve that I put up as to what it does and the normal position of what it is. and I can walk you through that when that time comes as well.
So what you're going to see once the panel covers go on this unit, you're still going to be able to see your suction pressure gauge and your discharge pressure gauge. Nominal pressures, when the system is running, you're going to see anywhere between about 11 psi on the suction down to 3 psi, depending on how cold your glycol gets. Okay? Discharge is always going to be targeted at about 150 to 140. That's what the computer is going to cycle all your other pumps and maintain that pressure. We do that so that you get the most amount of heat that you can get out of that warm glycol loop, so you get your heat for your Zamboni water, okay? Which is about going out there at about 100 degrees glycol temperature. All right? Then you have 3 safety controls here, which are hidden behind the panel that you don't want anybody to touch them. If there's a problem, you pick up the phone, you call your service provider, and we can remote it. What you're looking at here, this is your evaporator. As Matt explained to you, this is chiller unit number 1. This is labeled as a GP1 pump, and I'll show you that switch on the main panel. Base of operations for this unit, when the package first gets a call to start, now depending on whether or not you're running the system in a return mode where your pump is run all the time, and on that note, on every cycle of temperature, if you're running on slab control, we will flip-flop on pumps. So you'll see first call will be pump 1, then the next call for cooling will be pump 2. And we do that for all of the pumps that are redundant. So pump 3, pump 4 on your warm glycol loop, pump 5, pump 6 on your condenser water will be cycled. All right. The other side, you have the compressor, and we'll walk around there for a minute. You have your compressor. You have an oil level indicator here. This is your condenser, liquid line dryers. And on the warm glycol side, when you get a call for cooling, pump's going to start. The pump will speed up to 60 hertz. Then you're going to hear GP1, or whichever one if it's compressor 2, because we, again, flip-flop these compressors. We change the rotation every single start time. You're going to then see this Belimo valve on the warm glycol side open. Now this valve has a 2.5 minute stroke, so it's going to take 2.5 minutes to go from closed to full open. At a minute, the compressor will start. Okay, that helps us with discharge pressure and everything else, especially on a cold start if you've been off for a long period of time. So you'll notice that's going to start running, and then everything will start firing up, and the warm pumps will start to spin up to maintain temperatures. When it's finally ready, then you'll trigger, and you'll cycle probably at first one of your P5 or P6 water pumps, and you'll see that within the program as you watch the program run until the water temperature gets nice and warm, literally warm enough for a hot tub in there. And then you'll start to eventually see, depending on outside ambient conditions, you'll hear the condenser fan start to spin. Currently, right now, what we're seeing based on these temperatures and run times and everything else, literally, we don't get over about 12 hertz, so you can barely even hear that fan run. And if it's cold enough outside, you get to see it make some nice snow, is actually what it's doing, because that water's that warm coming out of there. So this is your main panel. On this side of the panel, we have your main disconnect switch here. This is a T-handle that is spun, if you needed to shut it off, will be spun clockwise to the horizontal position. That kills all power to this package. All 480 will be dead. Everything will be shut down. The other thing you also have up here is the emergency stop push button. This kills all of the 110 volt control circuit power. Once you do that, that's it. It's rink off. Have a nice day. Your stuff begins to melt. Okay. On the face of this panel, these 3 LED indicators are for the soft starts for each of the compressors. Compressor number 1, 2, and 3. And you can see what amperage you're running on your drive motor, on your compressor motors when they aren't running. All right. Simco main panel. This is the annoying buzzer, which I will trigger. So main panel alarm horn. Very loud, very annoying. This blue silence button is your best friend. Okay? Press the button, it silences the alarm. The alarm is still present. If there's a problem with one of the compressors, if it's C1 on a general failure, it'll be here. General failure alarms are for number 1, number 2, and number 3. If it's a low oil level failure, which again is below, it's a trigger from the low oil switch on each compressor, it would be illuminated here. Compressor low oil level 1, 2, and 3. And if it's module alarm is the internal module inside the motor electrical box, monitoring discharge temperature, pressures, and the motor itself of that semi-hermetic compressor, okay? And that would be one of these 3 here, which would be illuminated. Thank you. Once there is an alarm latched into the system, the alarm has to be reset, okay? Not only will you have an alarm within the computer, because the computer runs everything, you will then have to clear an alarm here on the Unitronics screen. And of course, call your service provider. We have the warranty for a year on this, so you're gonna call us and let us know. We'll get up here, figure out what happened, and get it resolved, okay? In the case that that doesn't happen, or we request that you do something, within this Unitronics touchscreen here, you have several different push buttons. Status is the first one, and then within status, it gives you the general status of the system, whether or not we have a pump interlock from P1, P2, showing that we have flow for the system to run. DDC mode, that's the computer is actually calling to run. Alarm silence, which in this case, if the alarm was going off, that light would be red. And then compressor 1, 2, or 3 is online. You can go back here. There's nothing you can screw up here. There's nothing that you can mess with. You can press all the buttons you want. There's nothing that can be changed or hurt in any way. It is completely password protected. You can go to compressor 1 status. That status is going to show you whether or not it has a compressor start, its run status, anti-cycle. We only allow these compressors to start every other 20 minutes. We have to cool the motor windings down and then allow it to start, because we don't want to short something out. And you'll see that anti-cycle light lit here. It'll be orange. Oil filter fault, that doesn't come into play here. And then compressor loaders. If you happen to be watching that screen when a compressor first starts, you'll see these lights change in pattern as we load the compressors based on 25%, 50%, 75%, and then 100%. At 100%, CR4 is lit, stays lit for 10 seconds, and then shuts off for 10 seconds. That's an internal Bitzer compressor thing that keeps the compressor at 100% load. All right. Back from there. Alarms. Within alarms, any alarm that happens to come in on this package is going to be indicated here. Whether it's a DDC alarm, which would be a computer, or whether or not one of these alarms has been triggered, okay? Within the alarms page is details. Now, if there was actually an alarm in the system, we would press details and it would come up with that specific alarm, time, date, and what it specifically was, okay? And on the side of it, as I don't have one logged in here, on the side of it there would be a magnifying glass here. You'll press the magnifying glass and that would ask you whether or not right here it would say in blue and white, acknowledge. And you have to acknowledge the alarm once you've talked to us and we say, okay, well, hey, I need you to do this, and you would go ahead and do that, and then we would be able to restart the system. Then that unlatches everything. It clears the alarm within here so that then, as long as it's not a physical failure of a compressor component, you would be able to reset the alarm. It would clear it, and we could restart the compressor again. Okay? You have hour meters for compressor 1, 2, and 3. Handoff auto switches for cold pump 1, which is your cold floor pump number 1 over there. P2, again over there. Compressor 1 behind your back, 2 behind my back, and compressor 3 over there. Pump P3 and P4 are your warm loop pumps. Those are the ones over there against the wall. Compressor 1, 2, and 3. As you see, these have hand and auto, and then you have on and off. If you put this compressor switch into hand and the computer is not calling for it, it will generate a DDC alarm. Computer says, hey, you're not supposed to do that. Why are you doing it? And it will make that buzzer go off and generate that alarm. Cooling tower water pumps, P5 and P6, those are the ones attached to the sump tank. Subfloor pump, P9 and P8 down here. Those are the two pumps mounted high up on the wall for your subsoil heating. GP1, cold glycol pump 1, is the cold pump, the vertical pump mounted to the backside of chiller 1. Number 2 and number 3 over here. Cooling tower water heater, that's not in play here. There is not a heater in that tower because we drained back to the sump tank. The original design had an integral sump in this design. When this panel was built, it's just there. There's nothing wired to it. Cooling tower fan. Okay, there's two variations of how that fan outside can be run. One is in VFD, which we'll go over in a minute, which is that first VFD there, or it can be run in bypass. Bypass is the computer tells it to start and stop, and there's a contactor in the main panel that will spin the fan up to 100% speed as if it was a normal mechanically controlled fan. Whereas the computer likes it to be in VFD because we can then vary the speed of that fan and only use the power that we need to. But if there is a problem with the VFD, then it can go into bypass and the computer will take over starting and stopping the fan. All right? And the last and least is the Zamboni water pumps, P7 and 10. Those two small circulator pumps, which we'll show you in the Zamboni room, they're little circulator pumps that are pulling that warm glycol. When the package starts, then it will pull that heated glycol to the plate heat exchangers in there and preheat that water. Cooling tower, VFD, for the fan that's outside in the cooling tower. Green light should always be lit. Screen should never be blank. If there is, you have a problem, all right? If it's red, there's an alarm within it, call us, let us know. Pump 1, cold pump 1 over on the side, pump 2. Again, remember, we flip-flop these on each start for cooling. Pump 4 and pump 3, same thing goes. You should always have green lights on these. If you have a power failure, we have power and phase protection within the panel. The second that it sees any kind of blip, it will shut everything off, control-wise, okay? It'll dump the 120 volts within control power within the plant, and everything will go dead, okay? When the power comes back and it's right, then it'll reboot everything and repower everything. If you have a power failure, it's always a good idea to come down here and double-check the VFDs and make sure that they're all have green lights. If not, read the screen, it'll tell you whether or not you can reset or not, and it'll be one of these buttons here. And it'll just say reset, boom, everything will be fine, and restart and good to go, okay? So in here, I'm gonna just quickly log out here. As you can see right now, I'm remoting in from out there, and Toronto can do that too. If we have program issues or whatever, we can make these changes remotely to the system. You have two variations. Now, if you have other people other than yourselves that are going to look at this, take readings from this, there are two variations to come in on. One is operator, where you cannot make any changes at all. The other is supervisor, where you can change your temperatures, okay? So operator is a view only. So you have operator up here, and you have supervisor down here. And just, if you can't remember something, the training videos have been put here as a desktop icon. Everything that I'm going over with you will be reiterated within these videos. Go ahead, sit down, watch them, get more familiar with it, okay? Or pick up the phone, ask the question. So in operator, this is your home screen. You have outdoor air, temperature and humidity, and the fact you have no active alarms. If there was an active alarm, you would see this in red saying active. From home, we go to Rink Control. Now this is where temperature changes are going to happen and schedules are made. Whether or not you decide to stick with these temperatures or you decide that you're having a big tournament and let's say you wanted to run the system in return mode, whatever you wanted to do, this is where you would do it from. But remember, logged in under the supervisor password, okay? You have night targets, you have game targets, you can set a game schedule. Game runs the pump all the time. If you choose to do that, there's a 7-day schedule, we will go over that. You can set that up if you like. It's not a calendared schedule, it's a 7-day. So it's Sunday to Saturday, okay? Same with the nighttime schedule. Anything that's not game or night defaults to day. So if you choose to not put any schedule in here at all and just pick a temperature or run your temperatures however you like to, the default will always be day to slab, okay? So you have your individuals, as you can see right now, we're in day. So I actually have a little bit of a night schedule in here right now, and what it's telling me is that at 17:15, at 5:15 today, it will then go into nighttime. And what you'll see is this green box will transition down to this green box here, to 24, okay? And you guys can play with these temperatures, see how the ice is, see how it is. Again, the colder you keep it out there, the less this is gonna run, the better your ice is gonna be. Everything's gonna be happy, fabulous, and you guys are gonna, you know, save a ton of money. System information. Ice slab temperature, you have a sensor in the floor. Rink temperature, rink humidity, the sensor's mounted on the far wall. Ice error, I'll go over that outside. And then you have return temperature, supply temperature. That's the glycol literally in the mains going out to the floor. And then compressor demand, whether or not the system is satisfied or not, or whether it's calling. One of the things within the touchscreen, which we'll go over in more in detail, will be pump control. If you're having a problem with a pump, you'll be able to take a pump offline here. You can actually pull the drop-down box and disable that pump. Okay? System control, again, this is the basically main switch on the computer side. If you choose to rink disable, you're literally hitting the light switch that shuts everything off. Walk away, come back in 2 days, and you'll have a frog pond. Slab mode, you can change from slab mode to return. If you're having a really big tournament, something's going on, you really want to keep up on it, you're cutting every 45 minutes, whatever, you really don't want to rely on that, you want to just keep everything running, you can go ahead and switch to return mode. Once you do that, it switches all your temperatures over to here. If you don't have anything programmed in night or day, it'll switch it right to day to 8 degrees. 8 degrees is the lowest you can go. The computer won't let you. Why? Because the glycol freeze point. It won't, and trust me, that's some cold glycol going out there. Okay, system flow. Basically showing you P1, P2, showing you your glycol in and out temperatures, showing you your slab currently, and your target currently. Compressor 1, 2, and 3. Here's those GP1, GP2, GP3s. When you see these come online, you will actually see these spin in the bottom. And then you'll also see your Belimo valves open as soon as it decides to start one of the units. We have sensors all over that we're monitoring at all times because that's how we base keeping this warm loop warm so that we can cycle, and you'll see the Vfd speed come in above P3 or P4, whichever one we cycle, okay? And you'll see those speed up and speed down, maintaining that glycol loop temperature, right? That's your HX1 heat exchanger over in the corner over there, and this is water. TT20 is actually tank water temperature. In that far right side of that tank is a sensor down low. That's the actual water temperature coming back. And then this one's actually leaving the plate. Condenser control, and all these temperatures in here through the week and a half of commissioning have been dialed in. That's what these are all here for. These are all here to make sure that this thing runs exactly as per design. That's what all these settings are for. So they're pretty much dialed right in where they need to be, and everything runs great. So please don't mess with them. You have max discharge pressure here. Again, as I stated before, you're going to see anything from about 120 to 150. And that's absolutely normal on discharge pressure. And then these are just basically glycol loop temperatures. Water temperature from the tank and water leaving the plate heat exchanger. And then fan ramp target. That's set for 94 degrees. That looks at this temperature right here. That is what tells this fan to tell this VFD to start speeding up. And it's not going to go up and down, go crazy. It's going to go very slowly, and it's going to maintain a constant, consistent level. Heat pump screen. You can enable or disable any of the heat pumps here. Again, I will go over demand limitation. If you want to save some energy, you can take one of those compressors off, set a schedule, say, hey, I only want to run 2 machines. you can go ahead and run 2 machines. It's fine. You'll have more than enough tonnage to do that with. It will cycle, even if you enable your demand schedule, it will still cycle the compressors. So it'll go 1, 2, 3, then 2, 3, 1, and then 3, 1, 2. So even though you've got this demanded down to 2, you're still going to cycle each of the units. So you always have one in backup. Lag start delays. This is how long it takes before each compressor starts. So once you start the first one, then the data, if you're running in day right now, it would then take, after the first one starts, it will then start counting, in this case, 15 minutes. You can increase these times based on the load that you have. If you go to night, you may decide that you want to bump that up to 60 minutes and wait for that last machine. Let the other 2 run. Maybe they'll pull the load, and then you'll never have to have that third one start. Energy savings. Control data, lead lag, fixed rotation lead is currently at 3, but we're not running that way. You have the option to run runtime equalization. You can run fixed, or you can run auto. Auto does, as I described, 1, 2, 3, 2, 3, 1, 3, 1, 2. Fixed rotation will run whichever you set it for, whichever is lead. If you set 3 for lead, then it's always going to fire 3, 1, 2. You got run hours, and then heat pump demand, lag start time delay, 20 minutes, time remaining, and then the supply temperatures. And then basically just reiteration of the flow of all the different sensors and stuff that we have all over this. Underfloor, computer has it set at 40 degrees. It's a number you can't change. It could be changed, but 40 is a good temperature. You don't need to have it on all the time. So that's the set point. Currently, it's sitting at 47 degrees in the subsurface. And again, just shows a portion of the warm loop again with P8, P9 here, which are your warm floor pumps. And then it also shows P7, P10, which is your Zamboni heat pumps. You've got runtime data here. There's a couple of pages here for all of the different machines. Page 2, page 3. For the pumps, everything that we look at and control is here. Alarms page. This is the analog alarm page. This is basically telling us ice rink temperature, the current reading. What is the high limit? Set for 28. Low limit, 15. That's a cold slab. Rink supply temperature, 14 degrees. The low limit is 1. Discharge pressure is 199 PSI. We have it set 1 PSI lower than the actual physical controls will actually trip the machine out. So we get a computer alarm first. Go to digital alarms. Digital alarms basically is if we called for something to run within the panel and it didn't start, you're going to see a digital alarm come up here. Then you're also going to see in the alarm log, you're going to see your dated timed alarm here. So as you'll note, it says alarm to normal, normal to alarm. So if something comes in, it's going to go normal to alarm state, and then when it is fixed, it goes from alarm to normal state. Okay? Trends I'll go over out there because it's easier. Conventions is nothing more than just showing you that if somebody comes in here and turns a pump into hand, it's going to be yellow on the page. Somebody's messed with a switch. Should be an auto. If it's in red, it's an alarm. If it's green, it's computer's calling for it to run. And if it's blue, then it's ready to run. Anti-cycle time, as we talked about, 20 minutes. If the system shuts a compressor off before that 20 minutes, you'll see an anti-cycle time on the heat pump screen. You'll see that, and then you'll see a timer counting down before it'll allow it to start again. Or it just started, and it has to count down that time. Quit. This is where you quit. You quit out on quit. You don't quit out on your X. And again, supervisor. If you want to make changes, comes up as supervisor, your password is Rink. Take the keyboard, R-I-N-K, enter. There we go. Now you can move in, you can come in, you can make temperature changes. You can do whatever you want to do. Go in under operator, no changes. You can go ahead and play with it all you like. It'll revert it back. But Rink is your password. All right, so if I'm in here, I'm going to quit out. Right. And then minimize your keyboard, and there you go. All right. I'm going to trigger an alarm just so that everybody can hear it. And then we will also trigger the Freon alarm. And here goes the panel alarm. Again, your friend is the blue button, all right? And because I generated an alarm, now I'm going to clear an alarm. It clears it out. Now let's go up top, and I'm going to go to the refrigerant detector and show you guys that alarm so you know what to expect when that's going off. So I'm going to test the refrigerant detection alarm so that you know what to expect if this detector goes off. This detector will, this is a 0 to 500 ppm sensor. It triggers at 100 ppm. Okay? If you have an alarm, if it does test out, it's interlocked. You have to clear it. Okay? When that detector goes off, the exhaust fan in the engine room will start. The damper will open and the exhaust fan will run. All right? Again, anything over 100, this should always read 0. Anything over 100 is going to trip and set the alarm off, okay? Alarm's going to go off. Until this clears all the way down, you got to get below 100. The only way you're going to shut it off is this blue button, okay? It's a latching relay, all right? Okay, so part of what Matt discussed with you guys was hot water recovery off our basically 100-degree warm glycol loop. And those 2.5-inch pipes come into here into the Zamboni room where you have 2 pumps. And you'll see those that switch on our main panel in front called P7, which is this pump, small circulator here, and P10, which is the city water circulator here. Basically what happens is once the chiller plant starts and you're running one of the heat pumps, P7 will start. That warm glycol will come down into here, into this heat exchanger here, where P10 will then be running and city water makeup comes into here and circulates through that plate into this holding tank, circulating that fluid until the hot water heater over there calls for hot water, and this tank will be preheated upwards of 100 degrees based on demand. Again, if you're running a ton of water into the Zamboni, this may not get all the way up to 100 degrees, but there's thermometers here and there that you can look at the glycol temperature coming in and out of city water in, city water out of the plate. All right? Again, just part of the heat recovery loop in the system. All right? And that's it. Okay, so this portion is the computer training. This home screen is a mimic of the touchscreen downstairs in the panel. As we have talked about before, you have 2 variations. You have operator, which is read-only, and you have supervisor, which is to log in to make all your temperature changes to your sheet. Look at your trend logs, everything else. You can also look under operator at your trend logs because there's no settings to be changed within the trends, but you can see it there. The other item that's on this home screen is the file folder here for the training videos. So if there's anything that we've gone over here today that you need to reiterate on, go ahead into that, and there are some training videos. Some of the graphics may not look the same. They're slightly generic, maybe of another system, not specific to yours, but the preface is still the same. The programming is still the same. All right? So let's get started here. Click into Supervisor, I'm going to come down here. The password is Rink. This is the home screen. Within the home screen, we show date and time in the upper left corner here. Outside air temperature 36 degrees. Outside humidity at 78.5, but it is still snowing. Alarms, there are none active, green, that is good. If there was an alarm condition present, it would have a red active here. Anytime you want to sign out from this computer once you've logged in, if you're in Operator and you just go down there and touch, there is actually a screensaver function within that, and it will shut off automatically within about 35 to 40 minutes. It'll go back to the normal white home screen. Okay? When you're within and you've logged in here, you always want to use your quit button. Quit out. Do not red X out. Okay? In the upper left corner. Let's go to Rink Control. Within Rink Control, we have System Control in the upper left here. Rink Enable, Rink Disable. If you needed, for whatever reason, end of season, just turn the rink off. This is where you would do it. You would literally come in here, hit Rink Disable, logged in under Supervisor, click that, the whole package goes dark. Nothing starts. You will get no alarms. Nothing. It's it, lights out, put the key in the door, have a nice day. You have two options to run on this system. You have slab mode and you have return mode. In return mode, the pump runs all the time and we target a specific temperature, the lowest of which is 8 degrees, as you can see here in return. You can run return in a game target, in a day target, and a night target. Anything that's not programmed into the schedule down here in game and night schedules will be revert to day target. Day is default. In this particular screen, we have rink pump control, P1 and P2. These are your two cold floor pumps. Now, within the other screens, we also have this control over these pumps. God forbid we've lost a shaft seal. We have a problem with a VFD drive. We need to be able to tell the computer that we do not want to run that pump. Use the other one. So we would go in here and we would disable that pump. And I'll do an example here. I'll disable P2. Now, if I was in operator screen, it wouldn't allow it. Now I've disabled P2. P2 will not run. And in every cycle, every temperature cycle, it will run P1. Okay? But we don't want to do that. We want to be able to flip-flop, so I'm going to re-enable P2. Okay? System information in the center, ice slab temperature. This is just another read. You're going to see this temperature come up in different areas within the graphics. The actual rink temperature right now inside the rink, and I'll show you later where that is, 54 degrees, and your rink humidity at 48%, relative humidity. Your ice error, okay. Ice error is, we control on slab mode, half a degree above, half a degree below. So we currently have a set point of 22. When we reach 22.5 degrees slab temperature, we will start the system based on how many compressors we choose through other things that we're going to go over here, how much lag time before the next compressor starts, or compressor demand limit. If we only choose to run 2 machines, then we can have that in play as well, whether we run 1, 2, or 3 machines. So we control at 22.5. We will then start. You will see this cooling demand status change from satisfied to cooling. You will run those compressors, however many it's calling for, to half a degree below set point. So at 21.5, the compressors will shut off. Okay? When you're running in return mode, it's 2 degrees above set point, 2 degrees below set point. Okay? Because return picks up temperature much faster than slab does, we give it a little bit longer span before we start bringing compressors back on again. Right? So 2 degrees above, 2 degrees below. Now that is return temperature. So it will literally run the system down to 6 degrees, then shut the compressors off, keeping the pump running in return mode. So
If you're having a really, really bad weekend, you've got a ton of stuff going on, it's going crazy, 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 you can always put the system into return mode, simple click, it'll switch to that. That's the coldest that you can possibly run it. As long as you have your compressor demand set for 3, you will bring on all 3 machines, and you will try to maintain that temperature, and it will maintain that temperature. Okay. Compressor demand, based on the algorithm within the program, you'll see 1, 2, or 3 here once it calls for cooling. Okay? And as it starts to pull the temperatures down, which you'll see in the trend logs, it'll start cycling them back the closer we get to that temperature setting. That algorithm is based on a 10-degree max differential temperature. Okay? That 10 degrees looks at the return temperature and the supply target. Okay? So, sorry, slab target. So if we're looking at 22 degrees, my max DT is 10. So it's going to look for this return to get down to around 12. Then it's going to start cycling compressors back. If you're running 3 machines and you've reached that max DT of 10, at 12 degrees you'll start to see compressors start to knock off because you've already reached your set point. It's already got the glycol cold enough. We know we've got that 10-degree spread on the return glycol and the slab temperature. Now the rest is basically X time. We're as cold as we need to go. Let's just wait for that cold to get up through the slab. Ice thickness, all that, we won't even get into that. All right. In control set points, you have the ability in slab to run game targets, day, which is default, or night targets. If you're not using the rink, you may as well save a lot of energy. Run it up a couple of degrees. Most customers, I tell them the max you really want to do that is about 3 degrees. Remember that your alarm target is 28. If you choose to do 28, you've got to remember that by the time the system cuts on, you may hit 28.5. That will generate an alarm. There are other rinks that do run these systems that high. We've had to inhibit alarms, and I mean, they run the borderline of, I can't believe they have good hard ice, but they do somehow. Okay, so game and night schedule, as we had discussed before. I'm going to click on that. This is a 7-day schedule, Sunday to Saturday. Okay, it doesn't know the day of the month; it just knows the day of the week. Okay, in night schedule, I had programmed this just to do this, and we can make changes, and we'll do those now. So currently, as you can see the cursor, when I hover over it, it shows me that it's 0-100 hours to 0900. So 9 o'clock in the morning, okay? So that means that at 0-100 hours on Sunday, we will switch to night schedule. Then from 0901 in the morning until 17:15 at night, or 5:15 p.m., it'll switch back from day back to night. Okay? And that'll run to 2400. Okay? And then it'll continue back through to the next following day. It'll follow that around. So literally you're in this case, let's just say today is Friday. So we were in night mode from 7:15 Thursday night until 9 a.m. today. Then we switched back to day mode for a few hours, and then we went back to night. I had just set that schedule based on your ability to be here to flood and everything else. Just gave you a few degrees colder so that you were able to do what you could do. Now to change, the key thing, when you change these times, you must click apply changes. If you do not, it won't take it. It won't take it. Okay, so I put one in here, so I'm gonna make that change. So as you can see, I've got the arrow pointing up at the time. Now, do you have a time in mind that you would like?
Yeah, Monday mornings, 5 o'clock, 5 a.m.
Okay.
Go to 6 a.m.
Okay. So what I'm going to do here is I'm going to left click it, and as you can see, it gave me the iron cross. Okay. Once I iron cross, I use my delete key on your keyboard. Okay. Delete, not backspace, but delete. Okay. And I'm going to go down through and highlight each one, left click, delete. Click delete. Again, the training video shows what we're doing here, but we're going to do this change today. Okay, so now we're going to go from midnight. So I'm going to bring the cursor over here to the far left, and I'm going to hold my left key down, left mouse key. See the time pop up right there on the bottom of the schedule? It says 0:15 to 0:45 right now. I don't know if you can see that on the bottom of the screen. Right there. Okay. So I don't want 0:15. I want 0:100. So I'm going to let go. Now, unfortunately, I left a little blurb there by accident. So I'm going to move over a little closer. If I double left click, I can fine tune and I can add the time in here exactly how I want it. Remember, it's military time, so you have to be specific. The left side of the screen is 0-100 hours. Okay? The far right side of the screen is 2,400 hours. There's no 2415. It doesn't exist. It's not there. It doesn't happen. So you can either put that in there, you can either do that here, or you can cancel out of that if you choose to do it by your mouse. And it is a little bit easier with the mouse if you're going to do multiple days at the same time. So I'm going to fat fingers here. There we go. 0-100 hours, and we're going to go to 5 o'clock. So I'm going to drag this over while I'm holding my left mouse down to 5 o'clock. Now I'm going to go down. Holding it down right here, and if I choose, there we go to Saturday, 4:45, 5 o'clock. I'm gonna let go of the mouse. There it is there. Okay? So it's all there. We've changed that time. Make sure, apply the changes. Okay? Now they're there. If you want to check to make sure that they're there, just come back out of the screen. Go to one of the other screens. Go back to Rink Control. Go back to your schedule. Hover over it for a second. It'll tell you the time. Okay? Now, how about the nighttime side? What time would you like it to start to go into night?
5:15 is perfect. You want it to go lower?
Yeah, probably should.
So when do you normally end things happening here, games and so forth?
Last group's usually off by 10:30.
10:30?
Okay.
So you could probably go to 9:30.
Yeah,
Get in
usually
that
the last
last
cut,
slide.
it's usually, and you're probably running pretty hard. And then you guys can pick the temperatures that you want to run. And once you figure that out, given, this specific site and, how the rink and your drivers and everything else handles the ice, how bad they. Come on. All right, so we are going to go 9:30, which is right about here. Now this is where fine tuning comes in really nicely. So you want about 20. You're looking for 2130.
Yep.
Okay. So I'm going to double click this. This is what's going to make it easier. Now, when you do it this way, it's fine to do it this way. You got to remember 21:30. Okay. End time is 24. Click OK. There it is. Okay. So now what I can do is I know where it is. I'm going to mimic that box, 2400. I'll scroll down to Saturday. 2150, 2130 to 2400. Click that, apply the changes. Okay. So now that that's in there, and we'll double back on this. We'll just double check to make sure everything is in there and it took. There it is. Okay. Remember, only under supervisor can you make those changes. Operator, you can't do it. All right. So now back to Rink Control. So now what it's going to tell you is your next night time is 21:30 today on the 7th. Okay. So it's going to run that way through. So you're going to run at a 24 at that time, 24 slab. Okay? And at 5 o'clock in the morning, it's going to restart and look at the new target of 22 and run the machines. All right. Any questions? Okay, cool. Special event schedule. This is just another schedule that you had something odd going on. I mean, you guys are pretty much just hockey guys, so
Yep.
you probably wouldn't have to use it, but you would then enable your special events target here and set a temperature in here and then set a schedule for that. Okay? Remember, if you set a game schedule, game temperatures targets are up here. You would have to put those game targets in here based on whether or not you're running in slab or return and pick those temperatures. Okay, system flow. Upper left corner, your current slab reading, your current slab target. So as we discussed before, we will fire at 22.5 degrees based on that, and you'll run down to 21.5 and then shut off. P1, P2, again, you'll see the VFD speed references here in black above it. You'll always see those at 100%. You have your supply temperature, return temperatures here. In the middle, you have your suction pressures of the freon of each one of the heat pumps. They go to 21 when the system shuts off because the compressor equalizes. Totally normal. You see the Belimo valves here for the warm glycol for the condenser cooling. You'll see those read open when the compressor calls to start. You're also going to see your glycol pump here, your cold glycol pump mounted on the chiller skid. You'll see that start and you'll see a green band fire into here. Okay? And again, based on rotation, depends on which one it's going to start first. It's an auto rotate, so we'd have to look to see which is the next call to start. In the bottom here, we have some more temperature sensors, P7 and P10, which I will show you that later. Your subfloor pumps, P9 and P8. Again, more sensors. I will tell you that if you happen to notice when the underfloor does call to start, and the underfloor currently is set at 40 degrees, and there's a sensor down in the subsoil. What's going to happen is there's logic in the program that's going to start looking at temperature sensors, because it's very important that we keep this whole warm loop warm, because that's what gives us our discharge, our proper discharge pressures for the systems to run correctly. We've got programming in there now that will cycle the pumps, P8, P9. You're going to hear them start and stop. You're going to see them start, stop, start, stop, all based on maintaining a proper glycol temperature to keep the compressors running correctly. Okay? Because that underfloor has, 500-600 gallons of cold glycol sitting under there at 40 some odd degrees. We don't want that 40 to come all one shot into a 100-degree system and crash that glycol temperature, crash that discharge pressure. So we're going to cycle those. Okay? Let it have a little bit, then shut it off. Let it warm back up again, then let it have it again. Okay? And it'll do that until it satisfies off, and finally that loop does warm all the way back up, and then it'll keep it running. Okay? Over here you have your P3, P4 pumps. Again, remember, as I said before, you have on different screens you have the ability, if you have a problem with a pump or something that you need to shut something off, and tell the computer don't run it. Before you would go downstairs and turn a handoff auto switch off, you have to tell the computer, I don't want you to run. Otherwise you will get an alarm. Instantly it tries to start that. It will generate one. So again, P3, P4, these are your warm loop pumps here. For the warm glycol loop, you could highlight one of those and enable disable. They should always be enabled because we flip-flop them on each other's start. You'll see here in the black the percentage of VFD run that you have. And you will, as you watch the system run, you'll see that speed up and speed down based on glycol temperature to maintain head pressure. This is the water side of the heat exchanger. This is your tank temperature and your leaving water temperature going out to the cooling tower. All right, any questions on this page? Okay. So that was system flow. Let's go to condenser. In condenser screen, we have all of the commissioned temperature settings here, pump cut-ins, pump cut-outs, fan cut-in, fan cut-out, reference latch for the water pump, P3 cut-in and P4, I'm sorry, P3 or 4, max reference of cut-in, and P3, P4, max reference of cut-out. And these are percentages on the VFD, just how we control the discharge of the system. And you'll see as you watch the system run, you'll see how those come into play, maintaining that pressures and temperatures right where we need them. Your P5, P6 pumps here, your water temperature, your water tank, your fan ramp target is 94 degrees. That temperature is being read off GT22 right here. So literally, as you see, this is 67. We will not start ramping this fan at minimum speed until 94 degrees. So that water is toasting warm. You're feeling a chilly day, go climb into the tank. You'll get nice and warm really quick. Any questions here? Okay. Again, just another rereading of slab temperature reading up here in the target. Heat pump screen. In heat pump screen, again, we have heat pump control. If there's a problem with the unit and we need to take it offline, this is where you would do it. You would either enable it or disable it. If there's a problem with that machine, that's where you would do it. We have our lag start delays. Again, we can adjust these up based on how you feel your system is doing. If you think that you can tolerate expanding those times, it just means more energy savings for you. Right? Especially on the night side of things, your night delays, probably going to want to increase these. You know, you can go upwards of, you know, you can wait 30 minutes for the second machine to come on, and you can take the third machine and say, well, I want you to wait an hour after that. There is a limit to how far out you can go. And you'll see that. You can punch in a number like, let's say, 90 minutes. And whether or not the computer will take it or not, you can actually have that machine go wait an hour and a half before it tries to restart that machine. Okay? Oh, no, see, it didn't like it. The max limit is 60, kicked it back. Okay? So you can actually literally let it wait that long. Okay? Which is good, because if it can make set point before it needs that third machine, you just say start a whole other machine. Right? Money in the bank. Lead lag control. Right now I'm currently in auto mode, which means it'll flip from base. Current lead right now is compressor 3, so it's going to start compressor 3, then compressor 1, then 2. The next cycle, temperature cycle, it'll start compressor 1, then 2, then 3, as needed, based on demand. It'll tell you here, you've got run hours. You've also got your hour meters down on the package. You've got heat pump demand here, based on how far off set point we are. That's where you'll see a demand here. Your lag start time, okay, 20 minutes. So it's always going to start the first machine that's in sequence to start first. Then the lag timer will kick in for the next machine to start, which is where you'll see time remaining. You'll see these two count down. Just a reread here again of supply and return temperature. Again, the starting and stopping of these compressors is based on that 10-degree max DT. That we look at the return temperature of the glycol coming back based off the set point. So if we're looking at 20 degrees, we're looking for 10-degree return temperature. From that point below, that's where we start to back things off. Okay? And this is just another graphic reread of all the different sensors we have. These are individual cold sensors that are on each of the individual chillers here. Your in and out temperatures. You also have in and out temperatures on your glycol, on the warm glycol leaving this specific chiller. You have suction and discharge readings also. Here's where you're going to see, you'll see a start command here when it calls to start, and then you're going to see anti-cycle come on, okay? And it'll have a timer underneath here. We do not allow that compressor to restart again within that 20 minutes, and you'll see that here. So to see anti there is a normal thing. Okay? Demand limit schedule. Okay, right now it's disabled. You can, if you choose, to enable this demand limit schedule. This schedule is how many compressors you want to run. Okay? If you try to go with one, you're going to run one machine all the time. It just won't shut off. Unless you really have a high temperature setting. If you're looking for 20 degrees, don't think you're going to get 20 degrees with one compressor. It's only 42 times. it's going to be difficult to maintain that. Two would be your basic minimum on this, to where you would be able to cycle and actually shut off and have everything, go dark. The schedule is the same as the other schedule. As you can see, there's already one set in here, and you can go ahead and change that if you like. You can set this so that you can mimic your night schedule if you wanted. You can have 3 machines during your day default period, but yet only have 2 machines at night. You can mimic and change that demand limit schedule and enable the schedule and only have that happen at night. All right? If you so chose, if you wanted to. Okay, so that's pretty much it on this page. You guys have got any questions? Okay. Underfloor, this is your control set point. This is a hard number in the computer. It's currently seeing 47 degrees. To where that's where you'll see, again, we talked about the algorithms of how we run these underfloor pumps and what we look at and how we cycle so that we make sure that we keep that glycol loop temperature warm. We want this TT11. We want this 100 degrees. We need it for your Zamboni hot water preheat. We don't want to kill that loop temperature when we start that underfloor pump. So we're going to cycle the pumps. Runtime data is just a reiteration of how many starts, how many runs for each piece of equipment that we look at. Pump 1, pump 2, warm loop pump 3, warm loop 4, subfloor pump 8, 9, and then there's another page. Compressors 1, 2, and 3. Cold GP pump 1, which is your individual cold package pumps. 2 and 3, and then page 3, which is your condenser water pump, cooling tower pump 5, pump 6, cooling tower fan, and then some spares, and then the Zamboni pump P7 and P10, which we will look at those. Alarms. There's actually 3 pages here. Okay, so if there is an alarm, you'll see a red button here. If it's not in the analog alarms, it could be in the digital alarms. You'll see it here. Okay? If one of those pieces of equipment, if somebody's gone downstairs and hit that e-stop alarm, you're going to see that lit up. Okay? Somebody hit that switch. You'll see it there. Okay? And then you have the alarm log, which is just telling you exactly what failed and when. And when did it return to normal? Did it return to normal? Did somebody reset it? It's all here. We know what goes on. Okay, trend logs. This is a fun one. This is where you get to see how you're doing. So within system trends, you have a Rink trend, heat pumps trend, condenser trend, underfloor trend, and then individual heat pump 1, 2, and 3 trends. Okay? So we can look at different things. So here we go with Rink trend. And this is one of the things you guys are going to be able to look at daily to see exactly how did you do. Can I raise my temperature higher? Sure, you can try 0.5 degree. You can try 0.2 of a degree. If you save money, if you save energy, your ice is great, you may as well do it. If you notice here, when I move the mouse, if you look at the lower left corner of the screen, it says cursor all the way at the bottom. It shows a date and a time. I'm going to move down here, show you this area right here, okay? The bottom, all right? As I bring the mouse to the point of that temperature read, you look down the bottom left corner, it tells me it's at 19.35 degrees and exactly what date and what time, okay? So you can see when your highs and lows are. Remember I said I could tell when you were flooding and when you weren't? Okay, I'll back up the trend log because everything's here and I'll show you exactly when that happened, all right? So in this particular trend log, under Rink Trend, we're looking at 4 things. We're looking at the slab reading, we're looking at, which is in purple, we're looking at the return reading, R1 return reading, which is this green line here. This is our return glycol temperature. So you can see at the lowest point, right before it shut off, if we look there and now look to the bottom, we can see that the return temperature got down to 8.8 degrees. Okay? Probably with 3 machines on, I would guess, to get that cold. And exactly what time it did that. And then you can see again when it restarted, hover right there, and it tells you at 15.48 degrees it restarted the pump and started restarting the compressors. Then we have P1 and P2 cold pump run. Now this is an interesting thing to check how long you're actually running this system and how you can try to save yourself some money and just update it. That's why I shifted. So if I go here, this is P2 down here. So P2, remember I said we cycle each pump every start. So if I go here, hold my mouse there and I look at the time says 5:49 a.m., right? So if I take that time there to this time here, 7:04. So now that tells me that basically an hour and 10 minutes, give or take, of off time that you have. The ideal thing you want to try to do here, still have good ice, but increase your off time. Now, that's what happened when I kept the ice at 20 degrees. Night, setback, and day. Okay. Now, when you go to a higher night setback, as long as the rink is nice and cold, all the doors are shut. How many rinks I walk into, they leave the Zamboni doors open at night. Keep the cold in the bowl, okay? I should have it with a smiley face on a t-shirt. I should have that. You do that, the package runs so much less. It really does. It keeps that cold within the dashers, and you run far, 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 far less. As you play with your temperatures, you'll be able to come in here to Rink Trend and see not only how long did I actually run, but how long was I actually off, and how many machines. Again, energy savings, and it's big. It's big. So you can move the mouse around. It'll tell you what temperature exactly and everything else. Now, within this, you have some tools here that you can use. In this upper left corner here, you see these green arrows? Okay, so now currently, I'm at the current read that we're currently getting right now, and they're just did another update. It did another scan. So I'm going to go back here. So I have a back arrow, and I have a fast back arrow. Okay, if I go back arrow 1, if you look on the bottom of the graph, you'll see it's got a date and a time. Right here, 3:35 a.m. and the date. Okay, so if I go back 1 click, you'll see that it shifted it back about an hour, give or take. Hour and 10 minutes, I think. If I want to go back really quickly, I'll use the fast backwards. Now, here's where I'm going to be able to tell how many floods were made. As we look here, we were under normal run, and somebody said, hey, can you drop the temperature? So the temperature got dropped, and here's a flood, here's another flood, here's another flood. Now this is basically just reading slab temperature. This system doesn't currently have an infrared camera, but you would really be able to pinpoint exactly when they went out, and exactly when the system kicked on, ran, and did everything. And you can see how the system started and then started to respond and return temperature reading. Again, you can look down here on the bottom and see that P2 was online, and how long P2 was online during that time frame that you did that. And you can go all the way back to the beginning of when we started the trend, when we first turned the system on. Oh, there's your cold water hose right there. All those high peaks are every time you actually went over that sensor, put heat over that ice. We know exactly when you did it. So your timesheet better not lie. So you have that information, and it's all the same for all the trend logs. You can go back and look at everything. Now, to get out of a trend log, this is the one and only time you're going to X out. That brings you back to here, okay? So we'll go back into trends. Heat pump trends. There's quite a bit of data information here, but it's all usable information. We use it when we're trying to look for a problem. We can also expand this out. I can make this much bigger, this screen. I can make it so that I can look at a specific temperature. I can look specifically here and tell you that, okay, here is compressor 1, compressor 2, and compressor 3. Tell you exactly how long each one ran. Which one started first? Compressor 3 did. Okay? Then compressor 2 came online, then compressor 1. But at the next cycle, it was compressor 1 started first, then 2, then 3. That's how we show a start. This is off, this is on. All right? And we just have discharge readings here. If you look up here, temperature scale 147.1, and you can look at these temperatures. Again, using on the bottom left corner, you can see this, the cursor, and you can see what your temperatures are. You can see that we have it tuned pretty well. It's pretty consistent. It's not all over the place. Then you have some other suction pressure readings here and everything else. Now, if I wanted to specifically look at something, on the computer, I'd use my mouse, I'd hold my left down, and I'd create a box and let go. And I can blow that box up, and I can specifically look at these specific temperatures or pressures that I happen to be looking for to see if there was possibly an issue, something weird happened. I could blow it up and see when it happened and what unit it happened to. Okay? Again, if I want to get out of this, I'm just going to X out. Condenser trend is pretty much the same thing. Again, looking in the upper right corner, we're looking at different things. We're looking at the warm loop, P3, P4, actual speeds of the VFDs we're looking at. TT8, analog input temperature. Cooling tower P5, P6, binary inputs. Again, looking at what we're running. Are we running P5? We're running P6. Okay? Looking at the actual starts and stops of actual speeds of the fan motors and different things. All right. Any questions? Okay, so next trend log is the underfloor. Basically, you're looking at the underfloor temperature reading, and you get to see here supply reading on glycol, return reading, and then the actual reading, which is hovering right in there around 47 degrees. Okay? And then whether or not what our actual target is down here. That's set at 40 degrees. And then whether or not we've started a pump. In this case, you can see that we have not started a pump. X out of that. And then we have the individual heat pumps. 1, 2, and 3 are all the same. So where we look at suction reading in red, we look at discharge reading in blue, and then our 4 temperature readings of cold glycol and warm glycol. So we can see specifically what is going on within that one chiller and the readings from it. Okay. So here we are. That completes the trends. Under conventions, we have what you'll see when you look at the screen. If it's yellow, somebody has put something in hand. If it's red, it's an alarm. If it's green, it's supposed to be running and is running. And if it's normal color, blue, that it's not yet been called. Okay? And you'll see some other things in here, some green lights, some turn on for valves. It's a pretty generic page, just covers a lot of things. Your anti-signal here, which you'll see that when we bring a compressor online. Again, when you're done on this page, you want to quit down here, not X out. You should only X out on trend logs, but you will quit here. And it sounded like the package just started. So let's have a look. No, it was my ears. Somebody was cleaning something. All right, so any questions at all? No? Okay. Like I said, you have the videos here at your disposal to be able to go through them. Put out of that, right here. Click into the training videos. And each one of these training videos in here, go ahead and watch, listen, reiterate anything. If you have any questions, give us a call. We can go over it. Again, not a problem. So you become more comfortable with it. Get used to making your schedules. Figure out your ice temperatures, what works best for you guys and your customers. And have fun.
Good.
All right.